So let's finish up our installation. So we've purposely stopped matters. Let's have a look using XMList by reconnecting first and imagining where we are in the installation process. So we've created a VM. Now when you create with XM Create, you do not actually register the VM with Xend for Xend management behind the scenes. So that's a separate step which we'll use XM New to do. But for the sake of invoking a one-off, an ad hoc, XM Create is the option du jour. So let's just note that XM Create with various settings does not register for long-term management, VM or guest or DOM-U with Xend, the daemon that is. So use XM New with various options, post-installation or provision, to register long-term for, let's just say, background management of the service. So as you can see with XMList at this stage, it no longer shows the item, the VM. So let's go ahead and find our history XM Create again. This will get a new instance going. And notice we're not in the directory, but it pulls it up either way. As we've mentioned, it reads etc xen as a default location for these particular files. Now, when you fire this off, you should be ready to quickly connect via VNC because things are happening behind the scenes. You can get a sense using XM Top, for example, as to the progress of the VM at any particular point. So here you can see the resources that it's using. It's using the majority of the CPU as is expected because we just fired it up. And it's waiting for us, hopefully with the ISO image in tow. So let's go ahead and do a VNC viewer connection. You can actually use XM as well with a VNC viewer connection. Now this should connect to the default console, which is 0. We have no other domains or DOM-Us, so this should be the default. Now keyboard control, mouse control is provided by VNC, so you should be able to use that as well. Let's move forward with the installation. We'll just quickly try to get through the Ubuntu install and have that up and running and commit it to the repository for XenD management, for behind the scenes XenD management. And it's actually in this case throwing the display off. Now if we notice that it doesn't fully fit the screen, it doesn't auto adjust, so this can be adjusted quickly by reconnecting. And now we see the proper resolution, so let's move forward. And things should move rather quickly. Just ensure that the keyboard is focused on that screen, and it should be as close to native performance as you're accustomed to with a standard physical system. So let's go ahead, and this should be out momentarily. And providing that the NIC support is properly configured, the bridge that underlies the NIC support, then the ISO image, when necessary, will prompt the installer to fetch a remainder of the Debian or Ubuntu packages from online repositories. So in other words, ensure that your networking environment is intact. Let's just take a look to be sure of that from a separate window. In fact, let's just reorder these windows. On the left, we'll have the VNC viewer, on the right, the remote system. So again, bridge control should show the bridge, and notice it's already been assigned the VIF 5.0, 5 meaning domain number 5, 0 being the first interface in that particular domain for ETH0. Let's give this a host name perhaps of Linux CBT Ubu Guess 1. And we can give the fully qualified name, and that should move forward. Let's give it a new user, Linux CBT user, from which it will derive the first name, and let's assign a password. A typical install. This should be no surprise, regardless of the installation that you're in or type of operating system that you are installing. It should just proceed as normal. And we'll just move forward this. So whether Windows, Solaris, BSD, etc., should be no big difference. So this is where Ubuntu sees the storage that's been provisioned for the VM, and we'll tell it to use LVM. That's fine. It sees it as roughly 8.5 gigs, roughly. It knows that it's a Xen virtual block device, although via the config file we've presented it as HDA but it still knows because it's within a Xen environment. You'll find that with VMware and the others as well, that they tend to know that they're being virtualized. So recall the disk option, we presented physical device path and presented it as HDA. Sometimes you'll see this presented as XVDA or XVDA 1 or 2 or a particular partition number, but usually the operating system, because the kernel is Xen aware, will know that it's being installed to a Xen virtual machine. So we'll tell it to use as much of the disk as possible. It should be 100% for Xen, and we'll tell it to write these changes. This is a proposal to root and swap, which is normal for such a small partition. And there was actually a reference to XVDA in the previous screen, but we're less concerned with the actual device names and more concerned with just firing up these instances, as we're just having a cursory look at virtualization within Linux. So again, as you can see, we have a simple config file. When you create a config file that drives an HVM DOM-U, the builder type is HVM, otherwise it's usually Linux for PV or para-virtualize DOM-Us or guests or VMs. Each guest or DOM-U or VM should have a unique name. So let's just ensure that that is spelled out. Where's our config? It's actually not in this dump, so we'll just mention towards the bottom that ensure that each VM or DOM-U or guest wears a unique name, as is required by Xen and is typically required by operating systems. Let's see what's happening with our VM instance. So this is flying along nicely, and this actually brought the screen a bit up, and we should be able to bring that back out and into this space, maybe over here. So no proxy is needed. Notice this is moving rather quickly, and you can just do XM top on the host to see how quickly it's moving. Xen top or XM space top, either or will work. And there you'll see that it's using various resources at various times. You also note that when you fire up guests or DOM-Us, the base OS, if you followed the suggestions, should use very few resources to function as a broker for access to the other DOM-Us. So notice that the CPU utilization, for example, is rather low on the base DOM-U. The memory utilization has a lot tucked away, whereas the other one has just about a gig provision. This is in K, so you can multiply it out. So it's about a gig. The base one has more storage available, and as we fire up new DOM-Us, then we'll subtract from DOM 0. So we can tell it to install security updates. It's just basic Ubuntu stuff. And we'll tell it to open SSH, maybe LAMP as well. That should be good for us. Get us a base system, so it's pulling in 198 packages roughly. Now the key to any sort of installation is that once the files have been propagated to the system, you ensure that upon reboot the system no longer reboots from the ISO image. So post-installation, that needs to be accounted for regardless of whether the system is physical or virtual. So continue installation and post-installation tasks. So of course we fired it up, and let's just say finish install and perhaps ensure that guest or DOM-U no longer boots from ISO image, which is the emulated CD-ROM. So we know that the config file has that specifier defined in its config file as a boot option. So if we quit this, for example, and modify Ubuntu guest1.cfg, boot DC now switches to boot C, for example, C for disk, followed by D for CD-ROM, which is the ISO image. So you could have another entry such as the following. C alone is fine, or C then D, and then that should boot from the hard drive. If you're skeptical, you can just do boot equals C. That should boot from the hard disk alone. Save the changes. Now, another thing we should note is that this instance is yet to be registered for long-term management by Xen. So when we do register it, the config will be read from the CFG file and committed to a native SXP file, which will include the appropriate XenD option for booting, which will be from the disk first, followed by the CD-ROM if necessary. Let's see where we are. This is the Ubuntu guest. This should be close to finish. Let's just bring these windows out. This is ready for grub at this stage. and it'll write it accordingly. So let's tell it to install the grub bootloader. Let's ensure that it has keyboard access. Sometimes you have to be sure that the mouse is actually focused within the screen, otherwise it doesn't accept your commands. And it's ready to reboot at this stage. So let's do continue. Now at this stage, this instance still knows that it's supposed to boot from the ISO image first. Let's do an XM list. Notice the domain's still running. Its ID is 6. Let's try to connect to it again. That means it's on the first console. Notice it still comes up with the ISO image. So the thing to do here is to get rid of the current configuration. We can shut it down from the remote system so it doesn't boot from the ISO image. So for example, we could do an XM shutdown in either the name or the domain ID. So let's go with the name, Ubuntu guest 1. That'll send a shutdown command to it. Additionally, if you do a netstat ntl in search of that 5900 port VNC, notice it's gone. That instance is no longer there, so you no longer have access to the console. And in fact, if you try to confirm it, it no longer connects. So XM shutdown, let's just say B1 XM shutdown, and let's just say the number or DOM name. Let's just say DOM name or number. We use the DOM name, so for us that's simply an XM shutdown Ubuntu guest 1, and this stops the instance and gives us the opportunity to re-register it. Now insofar as whether or not the Xen environment sees it, do an XM list, and you'll note that it no longer shows up on the list. So in order to start it, you'd have to do a create again. Now, to read the new configuration and add it to XenD management, this time we'll use the new command. So B2 for us is going to be XM new, and the path etc xen ubuntu guest 1.cfg. And this will register so the VM with the Xen management daemon. So adds VM to Xen, let's say XenD management for behind the scenes. Now, this is the section that requires Python support because XenD daemon is written in Python and parses the config files, the SXP files, as Python files. Now, to be sure, you can also do an XM delete, but if you don't see it, it should not be a problem. Let's say the name of the domain, Ubuntu guest. If you saw it registered on your system, let's say because you had done an XM new before as opposed to XM create, then use XM delete to delete it. So now it uses the config file and it commits that particular config file to long-term management such that when you do XM list, notice it shows up on the list. It's currently not in a running state. It hasn't been assigned an ID. You know whether or not the domain or DOMU or guest is available for usage, whether or if it has a domain ID associated with it. So the fact or that it doesn't have a DOM ID indicates that it's currently not running. So upon invocation, a DOM ID, as well as an applicable state, are applied to that particular DOM. So XM new does that, and then we can fire it back up. So B3 for us is going to be an XM start domain. So we'll say num or DOM name. And this fires up the DOMU. Let's see what happens when we try this. It's going to be, now we don't have the number which we'd normally use with, let's say, one of the other commands, so let's just say the name because there is no number at this particular point. But for other functions such as restart, suspend, shutdown, etc., the ID becomes available for usage for those commands. So let's do an XM start name, and that'll affect your scripts as well. So for startup, if they're entirely shut down, let's say you have a front-end web script, ensure that you specify the name of the DOMU in order to start it. So once this starts, we'll do an XM list to see where we stand. And now it's been assigned incrementally 7 as a DOM ID, a gig of memory, and 1 virtual CPU. Let's see if we can connect. Now, of course, a netstat should reflect the new listener 5900, and then subsequent DOMUs will be 5901 as long as this one's running and higher. Now let's connect, and here we see it booting from the hard disk at this time. Now, the XM new caused the registration of the domain with the new config file referencing the boot from the hard disk as opposed to the CD-ROM. So again, cat ubuntu guest 1.cfg, so it knows to boot from the disk as opposed to the CD-ROM, and this will attempt to bring the system up. Let's do an XM list to see what the current status is. So no status just yet. It hasn't come up yet. Let's see. Sometimes it gets stuck. Let's see what it's doing. And sometimes, well, if you see, for example, the QEMU or CEMU hard disk reference, it usually means the domain is fine and it'll boot from the hard disk. Sometimes you'll see it boot up and the CEMU hard disk is not presented, and that'll pose a problem in trying to boot your system. Now let's take a look. We lost our view, but it's now in a running state. It's coming up, and we'll try to connect again. That'll show it this time. Oftentimes when there are context switches in resolution, you'll lose your connection. And because we're supporting higher than simply standard VGA, this is likely to, especially if we install X, be higher. It's a server, we don't need it. So now we have this new system up. Let's try to log in. Now, by default, we usually can't log in as the root user on an Ubuntu system until we've set the password. So let's log in as a normal user. And there we have our connection. Let's do an ifconfig to see what the current configuration is. Now, by default, these systems will use, of course, DHCP unless you specify otherwise. So this 7550 is something we did not specify. So it has a 50 address, and let's do a netstat.rn. If we see the default gateway, we should be able to hit it. So let's send a few packets to it. And indeed it responds. Let's try to ping the host on its IP address of 105. If we're able to get out to the default gateway, then there should be no problems getting out to the host itself. And this tells us that bridging is working successfully. So although our bridge reads, again, let's just bridge control show, well, it's now 7 because, again, XM list indicates that the DOM ID is 7. So virtual interface 7, first interface, matches ETH0, but from the perspective of the node, it's merely ETH0. So Xen takes care of mapping, as we've aforementioned, ETH0 to VIF DOM ID dot, in this case, 0. And it's currently available. Gig of memory, virtual CPU is 2. Initially it was 1. And if we do a FreeM inside, we'll see that it appears to have a gig of memory. Although it's able to expand up to 2 gigs, it's only using roughly a third. And we'll do a DFH look at the partition layout. Well, it's LVM managed, so the larger portion or the lion's share is associated with the root file system, of which only 1.2 gigs were necessary to install a base Ubuntu. Then there's a boot partition on XVDA1. If we cat the contents of etcfs tab, for example, to see the references to these partitions, you'll see that, for example, in addition to standard proc, UUID for boot, and a block ID will give you that. So that's where it's pulled from. So if you do a block ID, for example, boot, or block ID, let's see if it's installed. That's going to be dev xvda1, and actually it's not coming back, so we'll look at that later. But the point is, it's up and it's run, it's accessible, it's ready for usage, and in fact, if we close this VNC window, it'll just continue to be accessible. And that's that. The DOMU is now up. We can manage it using XM and applicable commands. Perhaps the simplest way to install a DOMU is via HVM, or perhaps we should say the most stable, and the proper balance of stability and simplicity is via HVM. So HVM, let's say, provides the best balance of stability and simplicity, whereas let's just say PV is the most simple but a bit more complex to implement because of the various issues concerning shared kernels, distinct kernels, updates related to kernels, copying over the source file system tree, etc. So it's a little bit more hairy, whereas with these types of DOMUs, HVM DOMUs, they're dedicated spaces and they can share the same logical volume arrangement. So for example, LV display shows XenVol1 Ubuntu Guest 1, which is 8 gigs, which is using a fraction of the space available to XenVol1. So VG display, for example, XenVol1, so it's 100 gigs, of which we're using merely 8 gigs for. that particular space, Ubuntu guest 1. So for subsequent configs, for example, we could merely copy the contents of Ubuntu guest 1, make a few changes, let's say Ubuntu guest 2 after we've provisioned it. We could even script it out. Boot with the same thing, use a boot of DC as we originally did, change the name to 2, go with similar settings, and in short order have the system up. Additionally, you can mirror the system. So for example, if you take a look at the LV display on Ubuntu guest 1, let's take a look at this, and that's going to be dev. We just want to get this setting out by itself, so let's give it the full path. So if you're able to mirror, let's say, this dev tree entry, you'll automatically inherit the layout associated with the target system, which of course, let's pull this back. By the way, when you disconnect the connection or the login still exists on the console. If you do a TTY, you'll see this is the first TTY, so be sure to fix that. So if you're able to mirror that LV, that logical volume, you'll inherit this whole structure, and then you can just change the critical config files that describe, let's say, the host name from etc host name, just whatever makes the host unique, and the IP address and so on. So maybe update that file as well as hosts, as well as the contents of interfaces, maybe making the entry static and so on. So that's our first HVM. Let's keep this running. We'll log out just for security purposes and close this window for now.